you realize that this is really the right way to regain function for those who are disabled, not just in spinal cord injury, but also in stroke, traumatic brain injury, multiple sclerosis, and so on. For the whole 30-minute session, I will cover all about non-invasive spinal cord stimulation, present evidence about mechanism and pathway of transspinal magnetic stimulation and epidural electrical stimulation. What you won't miss about recovery of spinal cord injury is the mystery about central pattern generation. Finally, I will talk about my experiences in handling RPMS to regain function in spinal cord injury patients. Let's start with my work at very first time when I fell in love with RPMS. Let's say when I decided to use RPMS to overcome all problems found in spinal cord injury, such as motor weakness, neuropathic pain, spasticity, and neurogenic bladder. RMS protocols in spinal cord injury include painting with auto mode along the spinal column and extremities, muscle strengthening with burst mode, spasticity releasing with 5 Hz continuous, and muscle training with 30 Hz for 3 seconds. For this 34 years old female with spinal cord injury T11 HAE, before receiving RPMS treatment, she could just walk slowly with her long leg brace and walker. With once a week for 7 months of RPMS, she finally gained power of her proximal muscles of lower extremities up to grade 2. Right now, she is able to swim independently and turn around smoothly in the swimming pool. Now today we have just 2 kinds of non-invasive device that perform strong stimulation to spinal cord. One that is well known in the last decade is transcutaneous spinal cord electrical stimulation, successor following epidural electrical stimulation. The other one is transspinal magnetic stimulation that we will focus later on. A few months ago, Liu from China published this scientific study. It aimed to explore the effects of repetitive transspinal magnetic stimulation of different spinal cord segments on movement function and GAP43 and 5-HT expression in rats after acute spinal cord injury. 8 rats with T10 spinal cord injury received daily treatment with 5 Hz 1.5 Tesla for 8 weeks. Many techniques were performed, including electron microscopy, Western blot assay, and immunohistochemical assay. The study suggests that repetitive transspinal magnetic stimulation can promote GAP43 and 5-HT expression and axonal regeneration in the spinal cord, which is beneficial to motor function recovery after acute spinal cord injury. Another scientific study from France, Fu study with 180 mice performed with several techniques. Magnetic stimulation treatment was applied at 10 Hz, 10 minutes per day during 14 days. They concluded that magnetic stimulation modulates the lesion scar by decreasing fibrosis and inflammation, increased proliferation of spinal cord stem cells, and also decreased demyelination, which contributes to axonal regrowth, neuronal survival, and locomotor recovery after spinal cord injury. One technique shown here is proteomic study. The number of proteins represent changes in biological function, such as decrease in apoptosis, increase in exon genesis. In conclusion, the study showed that repetitive transspinal magnetic stimulation treatment modulates spinal scar formation, enhances functional recovery, inhibits demyelination and enhances neuronal survival and axonal regrowth, increases proliferation and modulates differentiation of spinal cord stem cells. All of this also become true with chronic condition in juvenile and aged mice. In the early year, in this study, 10 mice received 15 Hz of magnetic stimulation for 4 weeks over 9-week duration. Normalized basal mouse scales representing motor activity increased compared to control group, and horizontal ladder scale decreased in errors. It shows significantly better functionality recovery in magnetic stimulation treated animals. The progress in recovery continued even after cessation of magnetic stimulation. Together, in vitro study, the release of glutamine as a major excitatory neurotransmitter was significantly elevated in segments of spinal cord exposed to magnetic stimulation. Here it is. You should be surprised that there are some evidence base for recovery of volitional control after spinal cord injury, even in complete spinal cord injury. Here is a success story from Egerton Lab conducted transcutaneous spinal electrical stimulation at T11. On their training with stimulation for 1 month, 5 patients gained volitional control over lower extremities with power grading at least 2. In Switzerland, a researcher team led by Dr. Curtin in Lausanne conducted a brand new targeted neurotechnology using spatiotemporal epidural electrical stimulation to enable walking. They used a sensor at the feet to detect 3 phases of walking and stimulate each muscle groups in each phase to enable stepping just in 1 week after surgical implant. Neurological recovery without electrical stimulation achieved within 5 months on daily electrical stimulation walking training. This is a brand new non-invasive strategy for spinal neuromodulation to control human locomotion. It is successor following invasive targeted neurotechnology by epidural stimulation. It uses continuous spinal electrical stimulation to activate the locomotion networks in combination with rhythmic targeted activation of flexor and extensor motor pools of leg muscles in different phases of step cycle to further enable a step-like behavior. After severe cervical spinal cord injury, non-functional sensory motor network within a cervical spinal cord can be transcutaneously neuromodulated to physiological states that enable and amplify voluntary control of the hand. Here, 8 chronic cervical spinal cord injury subjects improve voluntary hand function within a single session of stimulation. After a session of the stimulation, combined with training over 4 weeks, maximum voluntary hand grip forces increased by 3 to 5% in the presence of the stimulation, and 2 to 5% when grip strength was tested without simultaneous stimulation. So, what's behind the success in recovering function after paralysis? Dr. Ricky Edgerton described the new pathways. Fast volitional recovery depends on automaticity in movement that controlled by central pattern generation in spinal cord. Strong electrical stimulation enables movement and so regain volitional and autonomic function. This simplified depiction shows neuromodulatory mechanisms for the recovery of volitional control after spinal cord injury. Following a spinal lesion, the designating pathway related to motor neuron is interrupted, while the propriospinal network below lesion mostly appears to be functionally silent and afferent input reduced because of damage and paralysis. Thus, the locomotor CPG does not receive an adequate amount of input, lead to inability to evoke motor patterns. An innovative treatment with multi-site electrical or magnetic stimulation of the thoracolumbar spinal cord with a specific motor training can reactivate part of the sublesional elements of the spinal network. Dr. Gregor Curtin finally has proven the existence of the cortico-reticular spinal tract as a spare pathway in recovery of spinal cord injury. Glutamatergic reticular spinal neurons with residual projections below the injury relay the cortical command downstream. The circuit reorganization mediated a motor cortex-dependent recovery of natural walking and swimming without requiring neuromodulation. This simply answers the question about volitional control in recovery of the spinal cord injury. Last year, Jacqueline reviewed plasticity mechanism underlying recovery from spinal cord injury with strong stimulation, like epidural electrical stimulation. either transcutaneous spinal stimulation or transspinal magnetic stimulation, which has strong electrical stimulation to spinal cord, should be explained with the same mechanisms. The first one is strengthening of monosynaptic connections between proprioceptive afferent and motor neuron. The second is the reorganization of the propriospinal circuitry around the lesion site and within the lumbar central pattern generator to promote rhythmic activity and high limb coordination. The third one is aiding learning of correct motor output with peripheral afferent input within interneural networks. This includes cortico-reticulospinal tract, as we mentioned before. For further understanding about the fact behind the recovery in chronic complete spinal cord injury, may I introduce Dr. Weiss Young's famous work. This paper, published in 2016 in Hong Kong trial with 8 patients, he failed to gain any function changes despite 2 of them have fiber bundles growing across the injury sites after umbilical cord blood mononuclear cell transplant. But in Kunming trial, all 20 patients received 3 to 6 months of intensive locomotor training. 15 out of 20 patients can walk 10 meters with rolling walker. 12 out of 20 patients did not need assistance for bladder or bowel management. The mystery of this amazing recovery is activation of the central generator for walking, micturition, and defecation, but only when womb receive intensive locomotor training. One thing that you should be surprised is that many spinal cord injury patients did not show improved motor scores despite the recovery of ability to walk. Dr. Weiss Young gave a short message in an online interview to rehabilitation doctors. He said that we need to bring the rehabilitation doctors away from negativity. You know, basically, the theory right now in rehabilitation is to teach patients to learn to live with what they have, to learn to live with disabilities. So, our goal is to teach them how to overcome their disabilities and how to regain function. Let's introduce you about central pattern generator for locomotion. Katie Wilkinson summarized features of CPG control locomotion in animal. For basic motor pattern, supraspinal structure is not necessary. Rhythm is produced by neuronal circuits contained entirely within the spinal cord. And the spinal circuit can be activated by tonic designating signal from the brain. That means the designating signals do not contain the rhythmic pattern that they evoke in the spinal cord. And the spinal CPG network do not require sensory input, but actually are strongly regulated by their input. Even though study of CPG in animals is over 100 years, but study in humans accepting the same features is not more than 2 decades. Peggy Mason from University of Chicago redraw a brand new diagram of original motor control in her book. Simple circuit involving motor interneuron can produce simple movement, whereas central pattern generators and brainstem motor control centers produce complex movements such as chewing, walking, and the like. Cortical circuits just send signals to produce action. The sensory afferents reach motor neurons and motor interneuron directly. Cerebellum and the basal ganglion moderate higher motor centers but do not directly connect to motor neurons. To find out the existence of the spinal locomotor CPG in humans, Clammer searched for clues for spinal locomotor CPG in humans. The first clue, stepping responses in those with spinal cord injury. Second clue, observation of air stepping in healthy participants in a leg horizontal hanging position. The third clue, indirect observations of the sleep-related rhythmic leg movements. The last clue, walking in human infants that stepping occur while put the infant stand upright on the moving treadmill. In the last 5 years, I personally found another 3 clues for the existence of the CPG locomotion. Together, with the 3 simple ways to activate CPG locomotion. The first one is Kenware's neurophysics therapy, previously known as the Kenware-Kramer clicker process. By performing mild resistive strengthening exercise with any gym instruments, more than 10,000 patients got their self-initiated chaotic rhythmic movements to heal many kinds of diseases, including paralysis.
So I'm Ken Ware, the founder of Nutritional Sciences. It's an area that I've been studying for 25 years, something that has very significant value to the physical and emotional well-being of the human being. The phenomena that we're studying is tremor. There's aspects about tremor that has incredible value to how our systems recalibrate itself and returns itself back to some physical and emotional integrity. Well, the tremor that we're observing is simply the person's system interacting with its environment at very micro scales. So what that basically means is we're using exercise, very mild stimulation, so the person engaging in the exercise, being relaxed, being composed, trying to move the exercise very slowly. Well, the health benefits are enormous. I mean, that's the whole thing. We're actually, when we're looking at the initial conditions of the system, when they first start to interact with these exercises, what we're seeing within that person's system is basically anything that contains a disease or disorder or anything, it shows up in those dynamics. And of course, what we learned many years ago was the fact that this system, left to its own resources, if the person learns to just stay out of it and let their system work.
The second one is TRE, Tension and Trauma Release exercise by David Bersley. He induced body shaking, beginning from lower extremity, spreading out through the whole body by doing some exercise to initiate muscle fatigue in psoas muscle. These automatic movements, initiated by CPG, simply releases tension and trigger healing process in the body.
So we're doing a very abbreviated form of the lead-in, and again, because Ellen it's very accessible to her, so it's not, we don't need to do a lot of preparation work. Okay, so Ellen, bring your knees up about 2 inches. So a main part of the exercise is as she's lifting her knees. Now you might be able to see her legs are shaking a little bit. Now you might think, well, she knows what to do. She's making that happen. She isn't. And I challenge any of you to try this. If you hold your knees in this position long enough, I'm willing to venture that your inner thigh muscles, your adductors, are not going to be able to stay fixed and rigid, but even though you don't want it to, you're going to get a little bit shaky. And so this is really our lead-in process, because we're starting the response in this part of the body. Then nice full breath. Good. Okay, so bring your knees up a little bit higher, but feet are still, yeah, we're just going to kind of get it a little stronger. So we're still, she's under a mild muscular stress right now because she's having to kind of consciously hold her knees. And so that's what's creating this process. Once it has enough momentum, it will continue on its own. So what I'm going to have her do now is just bring her feet flat and a few inches apart, perfect, and just kind of, now at this point we just sort of see what happens. And I, as the therapist, when I'm working with somebody, I'm looking to see, what's the opportunity? Is the body, is there something that's trying to release? Is there, if I've done it with this person before, is there something new happening? Is there a tight area that's not relaxing? And then so I do what I do sort of accordingly. So what I'm seeing is there's a good process here. A lot of movement is coming from her core. That's that psoas muscle I showed. There's a little bit of tension higher in her body, and her arms seem sort of a little bit stiff. So I know that her upper back is...
The last one, Yanxin Qigong, a traditional Chinese Qigong conducted by Grandmaster Yanxin. This is an ancient method of healing and fitness. Automatic movements occur in meditation manner. Some of the audiences who attended learning course with Yanxin were inducted to do involuntary movements activated by CPG.
重在训练中医新的概念上的，包括了思维、意识、精神严格的自我修养，使我们自身心理素质不劣，三者融为一体的一门学问。 心身并列。所谓性命双修，重点指的是中国气功传统气功的主要内容特点。我国传统气功，特别是道家功，它非常主张性命双修。它主要指的是通过平常对心性秉。
In my practices, CPG is a target to be activated for locomotion training. I move RPMS machine around to stimulate CPG at L1 spine. The lady got C3 incomplete spinal cord injury HAD. She almost lost all of her sensory below lesion while she can walk smoothly. She said that she never thought she can still get better on walking until she was stimulating L1 CPG with RPMS while walking. The young guy suffered from T6 spinal cord injury completely. He got the strong willing to move his leg doing stepping while getting stimulation with RPMS. But without RPMS, he cannot move his leg like this anymore. We talk a lot about locomotion in spinal cord injury. What about recovery of secondary health conditions in spinal cord injury? Here is the first paper, conducted RPMS for conditioning expiratory muscles in patients with spinal cord injury. 8 men with tetraplegia were delivered 20 Hz magnetic stimulation at T1 to T11. Maximal expired pressure and lung volume are increased, suggesting a 4-week protocol of functional magnetic stimulation of expiratory muscles improves voluntary expiratory muscle strength significantly. Again in 2016, Xiaoming from Cleveland, Ohio, applied functional magnetic stimulation at C7 and T10. They found that conditioning of the inspiratory and expiratory muscle improved lung volume and lung function significantly. They concluded functional magnetic stimulation may be a non-invasive technology for respiratory muscle training in persons with tetraplegia. As for bowel dysfunction in spinal cord injury patients, RPMS proves to be of useful invasive gastric emptying by applying 20 Hz magnetic stimulation at T9 spinous process. This paper also showed the effectiveness of functional magnetic stimulation in improving in chronic transit and rectal pressure. This can be performed with transabdominal stimulation at lower abdomen or sacral nerve stimulation at the lumbosacral region. For neurogenic bladder found in spinal cord injury, applying 16 weekly with 1 Hz RPMS, all subjects achieve volitional urination. The volume of urine produced voluntarily increased, self-catheterization frequency decreased, and the capacity of the bladder increased as well. In my practice, for bowel bladder dysfunction, I at first slowly scan over the whole abdomen with auto mode 11 or 20 for 3 to 5 minutes. Then I use auto mode 20 to point and shoot at 4 sites, 1 to 2 minutes per site with maximum intensity as tolerated. For the course of treatment, twice a week of treatment is preferable, but we need at least once a week. Total cost of treatment depends on improvement of bladder function. Usually, there might be some improvement over time and should be noticed by patients and caregivers in every visit. The duration and intensity of treatment should be adjusted in each session as needed. I try to show you motor training with 30 Hz 3-second protocol. This is Miss May, previous international dual model in Thailand. She has recovered some degree of her proximal leg muscle after 2 years of T12 spinal cord injury. While giving moderate stimulation to her leg, she also actively moved her stimulated muscles to induce the plasticity.
นะครับที่มีปัญหาอยู่ตอนนี้นะครับโดยการทำโหมดM3 นะครับ30 เฮิร์ตซ์เป็นเวลา3 วินาทีนะครับก็คือเหมือนกับเราไปฝึกออกกำลัง strengthen 3 วินาทีแล้วก็จะพัก6 วินาทีนะครับแล้วกล้ามเนื้อมัดหนึ่งนี่เราทำประมาณสัก10 ครั้งนะครับเราจะมาเริ่มต้นกันเลยนะครับตอนนี้ก็จะให้ผู้ช่วยมาลองเปิดตรงนี้เป็น3ตรงนี้นะครับเราเริ่มต้นแล้วก็ผมจะเปิดมาเป็นประมาณประมาณ 50% ก่อนนะครับนะ50% ไม่น่าจะได้ลอง 70-80% นะครับครับโอเคแต่ละครั้งที่ดังก็จะเป็นการกระตุ้นคุณเอเองลองพยายามออกแรงในการงอข้อสะโพกด้วยนะครับตอนที่ได้ยินเสียงนะครับโอเคครับก็เป็น active assistive ว่าคุณเมย์ทำได้บ้างอยู่แล้วนะครับนะงอสะโพกเลยครับดีครับผมก็วางไว้ตำแหน่งของโซแอสกับด้านบนของตัว rectus femoris นะครับคุณเองมีความรู้สึกไหมครับว่าโอเคครับผมทำตรงนี้ประมาณ10 ครั้งแล้วก็เดี๋ยวจากนี้ผมจะนะครับโดยการกระตุ้นตัวยิปเตอร์นะครับให้หดขึ้นมาข้างในนะครับลองดูนะครับผมจับกลางไว้แล้วก็เราจะหดขาเข้าข้างในนะครับหนีบขาเข้าอย่างนี้ครับครับหนีบเข้าครับแล้วเป็นฮิปแอดดักเตอร์นะครับหนีบเข้าครับหนีบขาเข้าครับหนีบขาเข้าครับ
This is an example of bladder stimulation.
ประมาณ 80% ครับก็คือตรงตำแหน่งของแบดเดอร์เลยครับผมจะออกแรงกดบ้างนิดหน่อยนะครับแล้วก็สังเกตให้ดีถ้าเราถ่ายทำไปนะครับสังเกตว่าการกระตุ้นตำแหน่งนี้เป็นการกระตุ้นตัวแบดเดอร์พร้อมกับตัวพอได้ไฟหน้าด้วยนะครับนะซึ่งก็จะมีอาการลงไปตามขาได้ความรู้สึกเป็นไงบ้างครับคุณเมย์วิ่งลงไปที่ปลายเท้าครับ
For take-home messages, volitional recovery of the spinal cord injury is now proven to be true. Central pattern generation, the CPG, is a key concept in generating locomotion. Let's find out every way to stimulate CPG. Non-invasive spinal cord stimulation, including transspinal magnetic stimulation, is strong enough to stimulate CPG, but recovery of locomotion should be achieved only with the combination of intensive walking training. So this leads to my new strategy in walking training. Do a lot more walking training with a more stable assistive device. Adjunct locomotion RPMS also promotes recovery of all secondary health conditions in spinal cord injury, such as respiratory muscle weakness, bowel bladder dysfunction, and even sexual dysfunction. Thank you for your attention.